Question number 7. Find the particular solution of the differential equation 49 d2y over dx squared plus 14 dy by dx plus y is equal to 49x plus 735, given that when x is equal to 0, y is equal to 0 and dy by dx is equal to 0. 10 marks. First, we're going to try and solve the auxiliary equation, which can be written as 49m squared plus 14m plus 1 is equal to 0. If you were to solve this, you can get 7m plus 1 to the square is equal to 0, and therefore m is equal to minus 1 over 7. Clearly we have repeated roots, and therefore we're going to use for the complementary function that y is equal to e to the mx into ax plus b. And of course this is y is equal to e to the power of minus 1 over 7x into ax plus b. Right. Now, what about the particular integral? We can pick an equation which is similar to the algebraic form of this equation. So we can say y is equal to alpha x plus beta, and differentiating twice, we're going to get dy by dx equal to alpha d2y over dx squared is equal to 0. Take these values and substitute into the original equation. Doing that, we should be able to get 49 times 0 plus 14 times dy by dx, and dy by dx is alpha, plus y, and y is alpha x plus beta, is equal to 49x plus 735. And if we compare x, the coefficient of x, the x terms, we can see that alpha is equal to 49. So that's going to give us alpha is equal to 49. And of course, comparing the constants, I've got 14 alpha plus beta is equal to 735. Solve this, you should be able to get 14 times 49, okay, plus beta is equal to 735, clearly giving beta as 49. That is 735 minus 14 times 49, and we get 49. So this is beta, 49. Now from here we know that the general solution is basically made up of the complementary function plus the particular integral, and the general solution will be the complementary function, which is e to the power minus 1 over 7x into ax plus b, alright, plus the particular integral, which is alpha x plus beta, and alpha x is 49x plus beta, and beta is 49. Now from here we can let x is equal to 0, y is equal to 0. And if we substitute all of that in there, we're going to get 0 is equal to e to the power 0 is 1, and then into ax, and therefore a times 0 is 0, b plus b, and b is b, so we've got times b plus 0 plus 49, and you should be able to get b as negative 49. Now what do we do to be able to find a? So we're going to differentiate this. So we're going to find dy by dx, and if we differentiate this, we can use the product rule. Okay, so u dv by dx, so u is e to the power minus 1 to the power minus 1 over 7x. u dv by dx, if we differentiate this, should be able to get a plus v du by dx, and v is a x plus b, and then differentiate u, you're going to get negative 1 over 7 e to the power minus 1 over 7x, alright, and then plus 49. The derivative of 49x should then be 49, and this one becomes 0. So we're saying that dy by dx, if we clean this up, is all of that. Minus 1 over 7 e to the power minus 1 over 7x into ax plus b plus 49. Now we can use dy by dx equal to 0, and then we can also use x is equal to 0. So if we were to do that, so 0 is equal to a times e to the power of 0 is 1 minus 1 over 7 e to the power of 0 is 1 again, ax, and then x is 0. Okay, so we can say a times 0 is 0 plus b. Alright, so that is b, and b is minus 49. Okay, plus 49. So 0 is equal to a minus 7, minus minus becomes plus. It's 49 divided by 7 is 7 plus 49, and you should be able to get a plus 56 is equal to 0, giving a as negative 56. Now that we're here, we're going to just state the general solution, that is the particular solution for this question is y is equal to all of that. So e to the power of minus 1 over 7x into ax, and a is minus 56. Okay, x minus b, and plus b, and b is minus 49. Okay, plus 49x plus 49. You can put the minus outside. You get y is equal to minus e to the power minus 1 over 7x into 56x plus 49. If you were to factorize this, you should be able to get 49 into x plus 1. Now that should be it. And here we are, 10 marks for this question. Not hard.